I've reworked this uniform pixels object a bit. I have a comment up here called the index where I put all of the members just clustered together. And that's... Oh, fuck, I just dropped all my coffee beans. God fucking damn it. You know, you'd think by the time you hit my age you would stop randomly dropping shit, but like, I don't know, Okay, anyway, so the reason I have this index is because I can easily go like this and just select everything, or select all of this, and populate an object somewhere else in the code. So it's basically, this is basically for cut and paste, though also I've made the trap values all negative values, and ordered them sequentially, so I have a quick checksum. So when I look here, I know, oh, there's 10 values. So then through here, I actually have some comments and things. I was thinking to have like this variable lock object on this, as I do on the uint32 object. But I think the variable lock object was a stupid idea to begin with, because I mean, it was cool to experiment with to see if like that was a possibility, to use like object.freeze on certain values that I want to be immutable after they're set. But the thing is by adding the var lock container, and I have my reasons, it's nested too deep, right? We can no longer address everything linearly like this. We have to create a nested structure. So too much nesting. Right? Nested layouts are difficult to define on the fly, so points 1 and 2 are kind of the same. You know, I said that you shouldn't encapsulate to prevent programmers from doing stupid things with the data. So maybe I shouldn't be a hypocrite, and I should stick to that kind of philosophy as I'm programming. So have a better reason to encapsulate than, oh, just prevent people from doing stupid stuff with it. Because if you keep on writing a whole bunch of code to prevent people from doing stupid stuff, you're going to end up with all this cruft all over the place. You know? Now, speaking of cruft, you could say that, you know, all these comments are cruft as well. But, you know, I'm fine with cluttering things up with comments to help express the intent of what the code's supposed to do, because when the code eventually breaks somewhere, knowing what the original intent will really help you figure out what's going wrong. And speaking of that, let's go revisit a thing about original intent. If we look at this, we see 1024. Originally this comment said 1024 equals 512 times 4, which is wrong, right? So if you were to like be reading through the comments and you see that this is wrong, you'd be like, okay, the comment's wrong. Okay, what was the intent? And well, the intent, and then I wrote some more comments here, the intent was for this texture to be able to hold 16 of these. And when I was thinking 512 times 4, I was probably thinking like this holds 4 of these, right? If we divide into 4 quads, if we divide this into 4 quads. But what I wanted was, you know, 4 of these on one axis, right? Because then 4 times 4, multiplying those axes, then you get 16, right? So now, so by seeing this comment, realizing, hey, that makes no sense at all, right? Should be that, right? 2048, and let's check, because now I'm unsure of myself. 512 times 4. 2048, yeah. So I don't usually count. In powers of 2, I usually only go up to 512. I don't go past 512 very often, so I'm not as sharp with that. So okay, now we have this comment here. 2048. This 2048 doesn't match this. So now, when we see this again, we'll know that this is a bug if we read the comment. So, you know, this memory should be able to fit 16 of this memory, right? And because 4 times 4 is 16, right? So you'd have to... We could write a little ASCII diagram to visualize what's going on there as well. So, why not, since we're already cluttering stuff up? So it's basically, I think we could just do this, where we put the, so we could, yeah, why not, you know? Let's go all the way. So let's, now obviously it's kind of obnoxious, and, the density of your code, right? I'm making the code much less dense by, you know, adding comments everywhere, which can create problems. It'll especially create problems if your code isn't very dense and everything's all over the place in some type of non-linear fashion. But since I keep everything linear as possible, it shouldn't be too much of a problem that my code isn't very dense. There's a lot of fluff in it. Okay, so we take all these, right, and we'll just copy this. Ooh, no we won't. We'll copy that, and then we'll go like this, and this. So, like, in your face, like, if this comment doesn't make sense, then, you know, this is what I'm trying to visualize, right? So this is, right, and then we do one of these where we, like in drafting class, right? So this is the span of the master memory. And this is also, the width. And then, you know, this one is height, and, but you know what? Do I really want to, I don't really have enough room. Well, maybe I do. Let's see. So if we put this here, we're kind of running out of room there. I do like this little padding here. I think that's enough to get across the idea. You know, if this is width, then, you know, this is obviously, if this is width, this is obviously height, right? Like, we don't really have to diagram that out. Let's just close this off a little bit. So let's do that. So since it is a diagram, what I can do is usually I make my diagrams a little bit more noticeable with a different comment style. So usually something like that. And then what you could do is, yeah, why not? And then usually I use a macron, which is a character name, which is like it's like an upper score almost, to kind of create the top of a box, and then on the bottom, you know, box it off like this with the underscore. So I get an underscore and an upper score. And so we got this nice little diagram. Obviously takes up a shit ton of space, but it really nails in the fact that, you know, and then we can, we could get a little bit more, we could go like this, we could do 512, you know, we could really nail this in there, right? We could be like 512, 512, and then, you know, 2048. Alright, so all of this should make it blatantly obvious that I got 2048 here, and this is not that. And then maybe we want to go one step a little bit more overboard. This is all capitals, right? So maybe we want, you know, 2048, you know, and that's, you know, hard coding this within the comments. But I I don't want this to ever be changed. Like I'm doing some of what I am doing is like like I'm mixing a little bit of Scrum style with a little bit of waterfall, where I have a very clear picture of what the requirements are for this software, and I'm trying to I don't want to build too flexibly. Like I want to be able to organically build the software and organically add on piece by piece. But I don't, just because I want to or be able to do that organically does not mean I want everything to be super flexible. Because if I make everything super flexible, then we're going to have spaghetti code. So that would be a no. So anyways, so we have that, and I was not recording, so let's just start a timer, and then hopefully we don't go over our time. Maybe once it hits 10, I'll stop recording. Okay, so we have that. Let's, I gotta make sure that this is still running, make sure to make any syntax errors while I was mucking around. That looks good. So the next thing we want to do is we want to go to where we're kind of like creating this object, and what I'm gonna do is on my right monitor, I will take the notes from here, right, and I can paste those on my right monitor for reference, right? So this is my like ghetto, I'm not using autocomplete, but yeah, maybe I'm not that smart and I can't remember everything. So we'll use the power of two monitors to have reference for what we're doing on one side and then the code on the other side. So I won't actually be, I'll be referencing these variables as I code, and then I'll stack other things that need reference as I am coding. And we are going to create the getter and setter kind of methods, or the getter and putter is what I'm calling them, for this type of object. And yeah, let's but the first thing we got to do is make sure that our unipix variables are better filled out, because right now they're almost filled out, except they're missing some things. Now I want to make sure that when we're using indirection, that we're using it for some type of reason that makes sense. For instance, maybe we want to consolidate everything somewhere, or we're using it somewhere else. So I need to think about that when I am adding more variables. Okay, so we got the texture handle, the texture slot, the array width, height, and components. And the new things we need, which I have in this list, we're just going to paste them down here we're not going to paste them down there like that. I'm going to paste them down there like that, and then what we can do really quick, right, we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So, right, so now since we're probably going to run out of room, we can just remove those comments. We have it really well documented what those mean, so that's not really necessary. And we can go down here to the master memory, paste those there, right? And then we gotta fill it out. So iso mem, and then we'll go over here, the master memory, and we can tighten up that spacing a bit. I feel like a dashed line might be nice. So it's like a... So when I use something like this, it's kind of a... My divisions, I try to keep them hierarchical. So this is the idea of a dashed line is to communicate a less strong division. So therefore, when you see these, you kind of understand that this is a big section, and then I'm kind of like dividing that into like a logical subsection with the dashed line. Okay, so the name is always going to match this, but it's going to be, we're going to keep it all lowercase. So like that. So that's what it's called in the sampler, or I believe so. It better be. Let's match case. Let's make sure. Yeah. So in the sampler, we want to just keep. We don't want to like fractionate our names. So keep it the exact same name. That's easier to think about because you got less variables to juggle, right, in your mind. And the more assumptions you can safely make, I think the better. It'll just make things right. The more assumptions you can make, the less mental payload you have, right? And then those saved memory resources in your brain you can use for like doing calculations rather than just mindlessly memorizing things. Okay, so the sampler value and the sampler location. We could, I believe these all have to eventually be positive values. So we could actually leave these all like that, or we could do like, since we have two textures, maybe we want like, I don't know, 801, 901, and 10,001. I don't know. Right, so that when we put these values over here, we can set the trap values to like 2. That way we kind of know where they're coming from. And the name for this, right? So the name will be master memory. And let's not forget our semicolons. It's not gonna crash on us. JavaScript does have semicolon injection, but let's try to be as proper as possible. So now that we've filled out those extra pieces of data that we're going to need, we're going to refresh and make sure we didn't break anything. And we did, because I seem to be really good at breaking things. And I can see what I've done. It's just, we had those extra parentheses and forgot to, close that off. So add a little bit of code, rerun, add a little bit of code, rerun. And I've still screwed something up. So we have an unexpected token. Oh yeah, and another mistake, kind of obvious, is we're not actually inside of an object. So those colons need to be changed to equal. And now I'm not so confident that this will work. Oh, well, there we go. Okay, so we've fixed all of our mistakes. Add a little code, make sure it works, add a little code, make sure it works, right? Because you don't want those mistakes to compound too much, or else it can be very hard to recover from. Like, I've scrapped entire projects because I added too much code at once and just everything broke, and then I tried to just keep on fixing error after error, and then I'm like, I'm done with this. After a whole day of doing that, you're pretty much completely demoralized. You're like, maybe there's a more serious problem with this code base if I have to spend a whole day, solving compiler error after compiler error. Okay, so we have that, and after we... Is this in the... Yeah, this is the adapter graphics, so we're kind of like setting up the initial objects, but we're not really doing any of that population down here. So we could look for the pixel array, because lower down we're going to find... so we have these guys. So the texture handle, the texture slot, pixel array, width, height, and let's add from our notes. let's just add the other things in here. Obviously, this gets a little bit verbose, but you know, the point was to make it easy to, and the name of this, so this is 4. The idea is just to be able to easily reference how everything is connected. So obviously you might be looking at this and being like, this is low-tech and hacky and cluttered and ugly. Yeah, it is. Right, but it'll help me see the connections, so that's why I'm doing it. So we'll take that same stuff down here and we'll do something similar. Obviously this is the master memory, so we'll just change that there. And then we'll close that off. So now we just have we have just a reference table. That's really just so I can control F on the pixel array, right, and actually get to the next relevant spot where it's used in the source code. So we have this, we know there's 10, so 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, 4, and then 3 is 7, 8, 9, and 10. Okay, so checksum, that is everything that should be there. And we can look at some of the logic, right? The scatterbrain logic that needs some cleaning up, but let's not worry about how horrible that is yet. Let's just look at what else we're doing here. A lot of this logic should go into the so this data array. So we should use like a put. We should use. I'm gonna stop recording.